Bismillahirrahmanirrahim. We continue talking about vectors, and I'm going to talk about vector operations. Vectors operations, like scalars, where you add scalars, subtract scalars, you can multiply scalars, you can divide scalars. Similarly, we have operation for vectors. We can add vectors, we can subtract vectors, we can multiply vectors. So I'm going to talk about this type of operations, but in vectors, operations are much more difficult than scalar operations. There are two ways to, I'm going to talk about here about vector additions and subtractions. Vectors, additions, and subtractions, okay? So in vector additions, there are two ways to do vector additions. You can either use what we call the graphical method of adding vectors, or we use what is called the analytical method. Okay? And the analytical method is generally the one which is heavily used in this course. The graphical method, there are two ways to do graphical method. Either we use what is called the tail to tip addition, or the parallelogram. The parallelogram method, okay, of adding vectors. Now a vector, as was mentioned in the previous video, a vector can be represented by a magnitude and a direction. So this vector here, the length of this line will represent the magnitude, and the arrow is going to represent the direction. So this vector is directed toward the right. Okay? We call this vector A, and we always put an arrow on the top to distinguish between vectors and scalars. The scalars, they don't have the arrow. The vector will have an arrow on the top, which means this is, if I put an arrow on this letter A, it means this is a vector. And vector is always defined by magnitude and direction. So if you give the magnitude alone, it's not enough. If you give the direction without the magnitude, is not enough. You have to give magnitude and direction. So this vector has a magnitude which is the length of this line, and the direction is the arrow. And this vector, by the way, I can move it in this space by keeping the same magnitude and same direction. I can take it anywhere I want. I will not change the vector. Okay? Then I have another vector which I call it vector B, and I put it like this. And vector B, let's take it, it has a smaller magnitude than vector A and a different direction. And this is the vector B, it has an arrow on the top. So vectors are always, they have arrows. And I want to add these two vectors. We call this point here the tail of the vector, and we call this point, this arrow here, the head. So a vector has a tail and has a head. So the tail to head or tip, we also call it tip, we call it also head. The tail to head method is, for adding vectors, is I'm going to bring the vector B, move it, keeping the direction the same and the magnitude the same, and bring it here. So that the tail of B will coincide with the head of A. Okay? So I'm going to bring the vector B here and put it here like this. So this is my vector B. Okay? Then, to add these two vectors, okay, I'm doing A plus B here. Remember, I'm doing this will be going to give me a vector which is called a vector C. Okay? To add them graphically to get the vector C, you go from the tail of vector A to the head of vector B, you join like this. And this is my vector C. Okay? So the vector C now is this addition of vector A and vector B. The parallelogram method is similar to the tail to head method, but I will show you now how to do it. So this is my vector A again. I'm going to draw vector A again, and the vector B, I'm not going to bring it to the head of A, I'm going to bring it to the tail of A and draw again the vector B like this. Okay, so this is my vector B. As I told you, we can move vectors anywhere we want as long as we keep the magnitude and the direction the same. This will not affect the vector. Now, if I do that, if I bring the tail of B to the tail of A, and then I draw, I'm going to do some drawing now. I'm going to draw the parallel line to A and the parallel line to B, and then I'm going to join again the tail where the tails meet to the intersection of the two lines. I'm going to join like this, and this will be my vector C again. And we notice if we have a ruler and we are keeping the dimension the same, this length is exactly this length, and this direction is exactly this direction here. So vector C through this method and vector C through this method are exactly the same. We call this tail to head method, and we call this the parallelogram method. And this is how you add vectors graphically. Okay, this vector C here, which is the addition of vector A and B, is generally called the resultant. And we will be using this word a lot in this course. We can have the resultant of a velocity vector. It could be a force, a resultant of we call it net force also, or resultant. Okay, so this vector C is called the resultant. Now I want to show you how to subtract vectors. This is the addition of vectors. I'm going to talk about subtraction. Imagine I have a vector A minus B, and this will give me a vector D, which is different, of course, from the vector C here, because here we are adding and here we are subtracting. We can write this actually as A plus minus B, which is equal to D, right? So we can add A to minus B. So let's see what is minus B. Our vector B is here, as you can see it, and I'm going to show you how to draw minus B. Minus B will be a vector with exactly the same magnitude, but opposite direction, which means in this case it will be inverted. So my vector A will be the same as the vector A here, and my vector minus B will be the vector which is this. So this is minus B. And I'm going to add them using the same way, the same method, which is the, let's say, tail to tip method, okay? So I bring the vector B, the tail of B, to the head of A, and I draw it here. So this is my minus B, and I'm going to add them. I'm going to add what? Add A and minus B. So I will get a vector D, which will be going like this. This is my vector D, which is equal to A minus B. And we notice that D is not equal to C. It's completely different. It has the same magnitude as C, but it has a different direction. And this is how you do a subtraction of vector using the graphical method. Now you can also multiply a vector by a scalar. You can multiply a vector by a scalar now. So I have vector A, which has this length and this direction, and let's see how you draw a vector which is 2A. 2A, it means I'm multiplying the vector A by a scalar, and the scalar in this case is 2. But it's not always 2. It could be minus 5, it could be plus 10. This is just an example, okay? So 2A will be a vector which has the same, it's another vector. I'm going to call it F, okay? And this vector F has exactly the same direction as vector A, but it has twice the magnitude. It means it has twice the length of this vector here. So this is vector A, and this is 2A, and this will be my vector F, which is exactly equal to twice the length of A and the same direction. If I have a vector now, minus 2A, and minus 2A will be exactly equal to, in magnitude, as this vector, but it will have the opposite direction. And this is how you multiply a vector by a scalar. Another way of adding, subtracting vectors, or multiplying a vector by a scalar is by doing what is called the analytical method. We have seen in a previous video that we can represent a vector by its components along the x, y, and z axis by using what is called the unit vector notation. So imagine I have a vector A, okay, which has a component axi plus another component ay, j, and a third component azk. So this ax, ay, and az are the components of vector A along the x, y, and z axis. Then I have another vector B, which has a component bxi, has a component bxi plus byj plus bzk. Now remember that this ax, ay, and az can be positive, negative, or zero. Okay, it's very important. If I want to add these two vectors, adding them, analytical method will be a vector c, as you know, we have seen that, it will be a vector c, which is the addition of these two vectors. And the way to do it is to add the x component together. So I will have ax plus bx, I plus ay, by, j plus az plus bzk. So the idea is to add the x component together, the y component together, and the z component together, and get a new vector. Now this here, this part here, we call it cx, which is the component of vector c along the x-axis. This is the resultant vector, by the way. We call it the resultant vector, and this is the x component of the vector c along the x-axis. Similarly, this here is the y component of vector c, and this is the z component of vector c. So the addition of these two vectors give me a new vector which has the component cx along the x-axis, cy along the y-axis, and cz along the z-axis. If you want to subtract the two vectors, if you want to do a minus b, okay, or b minus a, so a minus b, in this case, a minus b will be another vector. We called it d. If you remember, there was a vector d here, and this is the analytical method. Here again, we have to subtract ax minus bx, I plus ay minus by, j plus az minus bz. Again, these are the components of the vector d along the x-axis, along the y-axis, and along the z-axis. So this is how you add vectors, or you subtract vectors using what we call the analytical method, using what we call the unit vector notation. Okay?